Hi everyone, my name is Elie, and today with Celine we are going to talk to you about Blizzard new game Hearthstone. Just a quick disclaimer before we get started. This is a personal work and it does not represent in any way our respective employer point of view. That being said, if you are looking for a new job, Google is hiring, so if you are interested, come to talk to me after the talk. Had to do it, guys. And then with that out of the way, let's get started. So Hearthstone is a digital collectible card game released by Blizzard earlier this year. It is based on the universe of World of Warcraft, and it's an amazingly addictive game. So with everything which is too interesting, sometimes unintended consequences happen. For us, at some point during the last few months, we started to be more and more interested into how the game is structured, how we can understand it better and building tools for it rather than playing it, which at the end resulted by us not playing the game at all. I remember, like for instance, from May to June, I think I played only up to level 5 and probably like 100 games, which is a huge down from beta where I used to play every day. But it's an amazing game. If you haven't tried it, you should. It's free to play. It's available on your computer, Mac and PC, and also on a mobile version, tablet, iPad, and hopefully anytime soon in Android. So, looking at this, it also was a very good excuse for me because I finally convinced my wife Celine to come on stage with me and do a Defcon talk. That's something I really wanted for a long time, so that's her first talk, so please be nice with her. Alright, so what are we talking about today? Today we're going to talk about game complexity. Hearthstone have about 500 cards now, and complexity creates bias. And the question is, can we use this bias? Can we exploit them? Can we find things which make us give us an edge? And that's what this talk is about. We wrote about our research and sent it to Blizzard. I don't know if some of them are in the room, but we didn't get any response, so I think they're fine with it. You know, no answer means yes, right? So, why we wanted to talk to you. First thing we want to tell you about how to find undervalued cards. So each card has a value and the question is, are they better bang for the buck than others? The second thing we wanted to tell you, and the other thing we really kept under the wrap and we didn't advertise at all so far, is the surprise of Defcon is, can you predict what your opponent is going to play? Yes, it's possible, and we're going to show you how, to a certain extent. We also wanted to tell you about how to predict the game outcome. It's very interesting, except we don't have time. 45 minutes is too short, so we'll write a blog post about it. And of course, we wanted to tell you about the impending alien invasion. No, wait, no, not this one. So, how many of you play Hearthstone? Can you please raise your hand? Not everyone, okay. How many of you reach Legend? No one, okay. Well, sorry. That being said, for those who've never seen Hearthstone, here's what a normal game looks like. So it's a board game, it's a turn by turn, and it's 2 players. Each person is represented as a hero, which is inspired by World of Warcraft characters. You are at the bottom. Here I'm playing Valera, which is the rogue hero, and my opponent is playing Hagen, which is a solo player only hero. The game ends when one of the 2 heroes reach health pool, reach 0. The health pool is on the right side of your portrait. And so how do you kill people? Well, you use decks, and the decks contain cards. 30 cards for each player. It's a hard limit. You can do only 30, not 29, not 31, just 30. And each card has special effect. So every turn you draw a card, and the card goes into your hand. This is my hand, and you can see one of the cards is highlighted in green. It means I have enough mana to play it. The mana is the resource you use to play cards. Your opponent also have a hand. You only see the back of it, obviously because you don't want to tip people's hands. For those who are curious, no, the game do not know the card ahead of time, and no, you can't cheat with that. I checked. The mana pool, as I said, is depicted on the right side. It goes from 1 at the first turn up to 10 as a turn 10. After turn 10, it keeps being replenished, but do not increase. So the maximum amount of mana you can have at a given time is 10. So a card can be multiple things. They can be either weapon or spell, which you played immediately. They can also be what we call minions or creatures. You can have up to 7 on the board for each player. Yours are at the bottom, your opponent are at the top. Here you can see, for instance, I'm playing Van Cleef, and my opponent has 3 minions which are on the top. Okay, so that's basically what Hearthstone looks like when you play it. It's obviously designed to play on a tablet. It has really been designed like this. And they simplify a lot compared to Magic because, for instance, you don't have to deal with land, which is the resource economy. So it's very simple. They try to make it very, very easy for people to get in and get their first free shot before buying cards, which is how they make money. That being said, there is a lot of complexity, as we will see. Here's a quick video of me playing Hearthstone in non-ranking mode just to show you the game. So you can see this is my turn, so I'm playing. My card do a special effect, bring a new card into game. I draw a card which goes to my hand. I play another card and I click end of the turn, and then my opponent have a secret which is a trigger effect. And that's basically what a turn looks like. On the video it looks awesome because the guy plays really fast. Sometimes you have up to 90 seconds to play a turn, so you have to wait and drink your coffee. So some people try to actually play 2 games at once. So what makes the game so interesting are cards. Everything is a card. If you look at how the game is structured, actually your hero is a card. Everything in the game is modeled as card, and the card is the thing we're going to look at in depth in this first part. So a card have a minion, here the Elie, have at least 4 attributes. The first one is the mana, which is a cost you pay to play the card, as I said, from 0 to 10. And then you have basic attributes in this card, which is attack, 4 here, and health, 5. So that's the card, and this is a very boring card. I mean, the illustration is nice, but nothing special about this card. What makes the game fun is there is a lot of cards which have a lot of interesting effects. These are 3 of my favorite cards, Van Cleef, the Fairy Dragon, and the Cabal Shadow Priest. And what's very interesting is you can combine all those effects and do unintended or very special combo, and that's basically how you win the game. So finding good synergy between cards is one of the fun aspects of the game. So now that we know cards, the question is there a better card or card which have a better bang for the buck than others? How we find those? Well, let's start first with the theory. I know it's early in the morning and the head hurts, but bear with me, please. We're going to start with the basic assumption of how we're going to model this. The first thing is the mana cost is proportional to the card power, which means that if you play a 1 mana card, it's less powerful than a 2 mana card, which is less powerful than a 3 mana card. If you haven't that, the game is broken because everyone will play just the most powerful thing, which is 1, and overrun people. No, Zoo is not that overpowerful for people who play it. It is a little bit unbalanced, but not that so much. 2 is the power of the card roughly increases linearly, which means a 2 mana card is roughly twice as powerful than the 1 mana card. If this hypothesis is not true, it means that if it was exponential, which means the highest card would be vastly superior to the lowest card, then Rush deck would have no chance of success. As the opposite, if it was a log scale, then long-term games, which we call control deck, will have no chance of success. So roughly, the linear is something you need to be able to have the game balanced between short-term and long-term. It's not quite linear, but it's a reasonable assumption. Card effect have a constant price. It means that a Divine Shield or any effect have the same price regardless of the card it's in. There is no discount for a specific card, there is no secret, all of it's in the card. Which brings us to the fourth one, which is having a card has value. Remember, you only get 1 card each turn, so even holding a card has some value, which we call the intrinsic value of the card. And finally, we believe there is no secret. We believe Blizzard has no hidden component, hidden balancing factor, and what you have in the card is exactly what the value of the card should be. So if we were summing all the attributes, you would get the value of the card. The question is how you sum them is another question we're going to explore, but there is nothing secret about it, and we believe everything in the game, and you can actually look at it. So that's where we started. So how do we model a card? Well, as I said, the mana is the price, so the price is equal to the attack and the health and the intrinsic value of my Elie. There is nothing else on the card, so we assume that the mana is the price in mana is exactly the sum of those attributes. You put it into a linear function, don't worry, it's very simple. You say, well, 4 mana is 4 attacks, where A is basically what we call the attack coefficient, which is the base point, how much mana it costs to have one attack, plus 5 health, where H is the coefficient for health, which is the base point, how much one health point costs in mana, plus I, which is the intrinsic value of the card, which is how much mana does it cost to even hold the card. So with that, you can already, even look, without looking at the coefficient just yet, you can compare two cards. So take another very common card, which is the Boulder Fist Ogre, which is heavily played in Arena, and we can also put it in a equation, right? 6 mana is 6 attacks plus 7 health plus the intrinsic value, and we want to compare it to our Chillwind Yeti. So same thing, well, not really easy to compare, so we're going to be very, very high tech. We're going to go back to 4th grade and we're going to just divide by 6. Yes, that's really hard, I know. And then it gives you 1 mana point. So for 1 mana point, you get 1 attack, 1.16 health, and the intrinsic value of the card. On the other hand, we're going to divide by 4. And by doing this, you say, well, for 1 mana point, what you get is 1 attack and 1.25 health, plus the intrinsic value. And here you can immediately see that one of them get better bang for the bucks. The Yeti gets more health point per mana point than the Boulder Fist Ogre. And that's the kind of imbalance we're going to look for. Let me give you a more interesting example. Fireball, my most hated card. I hate to be killed by a fireball, but that's a very simple thing. For those who don't know what a fireball is, it's a big ball of fire that people throw at you and you die. That's what it is. And so basically this one is very simple to model. You pay 4 mana and you basically blast a guy with 6 damage or a creature. So very simple to model. 1 mana is 1.5 damage. Alright, and they're like, well, you know, a fireball is great. How about we make a giant fireball? It's called a pyroblast. Bigger, stronger, meaner. And the pyroblast is basically 10 mana, and for 10 mana this time you get 10 damage. Well, okay, but then in that case, it might be bigger, but the bang for the value is not that great. You get 1 mana, 1 damage, and you can immediately see that's not quite right. If you have 10 mana, you can play 2 fireball and a half for the price of 1 pyroblast. So the value of the pyroblast is less interesting than the fireball. What's interesting is this is a new version of the pyroblast. Earlier in the year, we had a pre-nerf version which used to cost 8 mana, where that time the mana cost was even lower than the fireball. Where basically before they adjust the value, we get 1.25 damage for 1 mana. So something is not right here, right? Let's compare the two. If you take 10 damage, it implies that the fireball should do 4 damage, not 6. And you're like, well, okay, but no, the fireball is properly priced. You should do 6 damage for 4. Well, in that case, I want a pyroblast should do 15 damage, not 10. Give me back my pyroblast. So that's basically the idea of this imbalance, right? Even if you look at simple coefficients, you can see that there are some decisions which are, you can debate. Of course, we don't have all the data that Blizzard have, and they probably adjust based on statistical analysis, but deep down the mechanics is something where there is some sort of this mismatch in complexity that is the basic core idea of finding undervalued card. Okay, so how do we scale that to hundreds of cards? More precisely, we're able to do 130 cards because modeling each attribute is a little bit complicated, so you have to parse text. It turned out that the card is really like a bunch of text that you have to process and say, oh, that's this attribute and so forth. So we did 130 for this talk. How do we do that? Well, we model the card as we did before. Then we use those cards and reverse the coefficient of each A, H, and so forth using linear algebra. Don't worry, it's not as bad as it sounds. And then you use those reverse coefficients to compute what we call the real value of the card. And then the last step is the easiest step where you say, well, here's my real value, here's my face value. You subtract one to the other, and if it's a negative, well, you find another value card that's as simple as this. Well, easier said than done, but not that bad. So let me show you on a very simple example, 5 cards, how it look like. And then when we know that, I will show you the real results. So let's take 3 cards which has charge. Charge is basically you put a card and the card can attack as soon as it is come into play. So we have 4, we have the Corcoran, the Rocketeers, and the Argent Commander. And we're going to show 2 more cards, which is which have Divine Shield. And the reason why the Argent Commander is in the middle is because it has both attributes. And that's one of the ideas of having linear algebra is you can commute coefficients. So as I said, this is the same price. So with 5 cards, we can make it work. And that's also why we can compare cards, is because you have this very complicated interleaving. So we do as we did before. We put them into an equation. So our card crown have 4 attacks, 3 health, plus C, which is a charge coefficient, plus I, which is the intrinsic value of the card. And we do that for the 5 cards. Trust me, it's correct. Then we're going to reverse the attribute coefficient. To do that, we put them into a matrix, which is basically a table. And we put them like this. You say, well, for 4 mana, I get 4 attack, 3 health, 1 charge, 0 Divine Shield, and 1 intrinsic value. That's the first card. Then I do the same thing for the Rocketeer, same thing for the Argent Square. And here you can see it has Divine Shield and charge, so you have 1 and 1. And then you add the 2 other cards, which has the Divine Shield. The top one was something, and the third one is the Argent Square. And you can see, so basically you have your 5 things. Then you apply 1 line of Python, which is the least square. And boom, you get coefficient. And the coefficients are 1 for attack, the A, -1 for health, 2 for charge, 1 for Divine Shield, intrinsic. And you're like, dude, that doesn't make any sense. You can't have a discount for health. Yes, you're right. It is because we only have 5 cards. 5 cards do not give you a good coefficient because there is too much instability. You need way more. But it's just for the example, so bear with us. It's an example. So now how do you find the real price? Well, now we're going to be back to kindergarten, where you learn how to add stuff. So you know you have 4A plus 2H plus C plus D plus I. So basically what you do is you say, well, it's 4 times 1 plus 2 times -1 plus 1 plus 1. And the price is 6. So the real value, according to our coefficient, is 6. Well, the card is fair, right? There is nothing different between the face value and the real value. So you're like, meh, not interesting. Okay, let's try again with one of the most undervalued cards in the game, the Argent Square. A lot of people said in the forum it is undervalued. Let's try again, right? So it's one attack, 1 health, 1 plus Divine Shield plus the value of the card. So it's 1 times 1 plus 1 times -1 plus 1 plus 1. Well, now it's 2. Wait, 2? No, the card is 1, right? And yeah, you're right. That's why it's an undervalued card. It actually should cost twice. So even with our bogus coefficient, you can always see that this guy is clearly undervalued. That's basically the idea we have. This is how it works. So I did post that online, and we got a lot of good feedback about it. A lot of people from Reddit, a lot of good comments. Thanks to everyone who pointed out. The most important one we got was, well, dude, you should take into account dependency, and it's actually true. That's thanks to Nia, who pointed out that charge should be basically a factor of the attack, because you attack for the amount of the attack. So we now in the real model use attack time charge. Same thing for Wind Fury. Wind Fury, now we model it by taking into account the attack of the card. The one where we have a lot of debate question is about Divine Shield. We don't know what Divine Shield should be. Is it just Divine Shield as a coefficient? Is it related to health? Related to attack? It's really difficult. If you have idea, let me know. The thing we got, so that's a comment from someone on the blog, which actually wrote me a long post saying, well, no, actually cards have a budget. And the budget is 2 times the mana plus 1. I have no idea how we come up with the idea. It is absolutely reasonable, and when you do it, the coefficient looks way better. It is true. I just don't know how this guy get it, but thanks. So after writing code and debugging and debugging and debugging, you have something, you run it, and voila, you get your coefficient. So these are the coefficient we got for 133 cards. You can see that the most valued coefficient is sorry, I must mention, because we use the budget idea that has been proposed, now 2 coefficient points is roughly 1 mana point. So basically destroying a minion costs you 5 mana to add to a card. A board damage costs you about 1.5 mana per point. Drawing a card costs you, a single card costs you roughly 1.5 mana. Divine Shield is pretty expensive, it costs you almost 1 mana point and so forth. We also have negative coefficient, which is basically decrease the price of the card. As you expect, having your opponent drawing card is the highest one, followed by discarding cards. Doom Guard, I'm looking to you here. And then we have Overload, which is the shaman mechanism, which you pay another price, right? So all of this seems perfectly fine, and we were really happy. And we had this guy, which is a bot damage. So we did something we thought was very clever, which was like, let's model single target and multiple target coefficient as different. That is a stupid idea. I'm going to show you why in a few slides, but keep in mind that we tried. More than in a few slides. So one way to visualize what it looks like as a result is you can put on a graph where the x-axis is how much Blizzard assigned as a card as a face value, and on the y-axis how much the algorithm believes the card is worth. So it gives you on the left triangle the undervalued cards, they are in green, and the overpriced card on the bottom right triangle. Of course, because we arbitrarily force cards to be either undervalued or overvalued, you're not that interested into the one which are close to the line in the middle, which is like fair price. What's interesting is the people who are clear outlier, and there is quite a few. The reason why we have a lot of low value cards is because when we model cards, cards which have like shared ability are mainly lower value. It's not because the algorithm favor one or the other, it's just because when we did model, and you can see it on the slide, most of them are on the left side of the graph. For higher cards, they usually have special ability which are not captured by this model. I'm going to show you another one for those special ability just after that. So, no more blah blah. What is the result? Well, one of the most undervalued cards is Soulfire. We do believe it actually should be at least 1 mana. Light of Justice is also undervalued. This one actually triggered a lot of discussion, but then a lot of people pointed out that they do pick it into the arena. It gives you 4 attacks for 1 mana, which is somewhat overkill if you think about it. Not surprisingly, Mortal Coil, Power Shield, all of them are perfectly, and Argent Square. You're here, man. I see you. And there's also Explosive Trap. Somehow it actually gives you something which seems reasonable to most people. The one which is a little bit bizarre is Sacrificial Pact. It's probably a bug in the code. And do notice we also have high value cards. The one which probably is the most overpowerful is the Fire Elemental, which the algorithm believe it's probably 7 mana, not 6. Something which also has been mentioned before by people just by looking at the cards. So somehow the algorithm gives you a reasonable result. So we believe we are on the right track. If you want to look at the full detail, all the coefficient, all the card rank, they're on my website. You can just go there, and we keep updating it as we update the model. And if you have idea on how to make the model better, as we said, let us know. So, how do you take it to the next level? So far, we have only used a card. The question is, how do you make it better? Well, it's really difficult, at least without extra data. And this extra data is how people play the game. Most of the other cards depend on the state of the game, and we don't have insight about it unless you have a lot and a lot and a lot of replays. Of course, Hearthstone being very, very new, we don't have that much replay, and it's actually not a built-in feature. So, fortunately for us, we get our hand on 100 games which are being played between May and June. We'd like to thank you, our anonymous friend, for that. Thank you very much. And it's not a long-term solution, and we really hope that Blizzard will give us the ability to see replays and allow us to do our own analysis. I do not believe it's a flaw in the game. I know it's in the terms of services that they don't want to do too much data mining on it, but having people to look at things is not, I mean, the game is perfectly balanced. There is no reason to hide anything. So with this data, you can do interesting stuff. The first one is you can actually price cards which have unique effect. Let's start with a very simple example to get started, the Twilight Drake. So the Twilight Drake is a card which is a 4/1 for 4 mana and have a special effect that when it comes into play, it's a battle cry, it will gain 1 health, 1 additional health for each card you have in your hand. So obviously the value of the card depends on how many cards you have when you played it. So you can build a model where you say, well, if I have 1 card in my hand, then it has 1 extra health. And then the real value is 1.3 mana. If I have 2, it's 1.9 and so forth, up to 9. You have a maximum of 10 cards. So plus the Twilight Drake, the maximum is 9, or it's 5.9. So the question is, now you have this table, you need to use the replay data to be able to know, well, how people play it, right? Are they mainly playing it with 8 cards in the hand, 4 cards, 2 cards? So you do it, you draw this thing, and this thing, it draws this exact graph. And what you see is the following. In the red, on the left side, you see when people play it with less than up to 4 cards, and the card become undervalued. Basically, if you play with 4 cards, you get 3 mana value out of your card. If you play it with 5 cards at hand, you have a 3.6 value, and with 6 you have a 4.2 value. So this is the first zone where basically the price of the card is just right. If you play it with 7 or 8, then you get a lot of value out of your card. The average real value of the card is, if you take the average 3.7, which is right next to what is the predicted face value. So based on that, we do assume that the Twilight Drake price is fair. It basically is exactly what it is. It's also interesting to show that looking at this, we get the same conclusion than Blizzard, so we think we have something which is very similar to what they have, except they have way better data and better insight. Let's look at another card, which is one of my favorite cards, which is Van Cleef. So what Van Cleef do is it will gain 2/2 for each time you play a card before it during the game. So all you have to do is, again, look at the replay and look at how many cards were played during the turn before it to get his value. And for a reasonable number of cards played before the game, I know you can go way below that, but for the reasonable number, if you have a 2/2, it's 1.09, so 1 mana if you play it just like this. If you add a second card, you add 3 mana, which is roughly fair. 6/6, you become to get a lot of value out of it, and when you play 5 or 6 cards, then the value of Van Cleef is just outrageous. If you plot it, very, very different plot. As you can see, Van Cleef is most of the time undervalued. It is. Even if it's a 6/6, which is 2 cards before it, 3 cards before it? No, 2 cards before it, then you already get like a 5 mana worth of your card. And for 4 cards before, you get a 7 mana worth of card, and so forth. So the average is 8.1. So the average value of Van Cleef today is 8.1 based on our data. So I do claim that Van Cleef is undervalued, and I believe the right value is between 5 and 7 mana. I know it would make Van Cleef harder to play, that's why I say we should not be 8, should not be 9, but 3, in my opinion, is way too low. It is not, according to this data, it doesn't make any sense. Most of Van Cleef actually I play on the ladder are actually 6 or 8. They're like, people play it 4 for priest, but otherwise they will give you a 6/6 or 8 Van Cleef, which are way too powerful for the price. So this is probably one of the cards which is the most undervalued. All right, last one. Flame Strike. We got a lot of questions about how you deal with AoE. So cards which have an area of effect. So Flame Strike is one of the simplest one. What it actually do is it do 4 damage to every minion of your opponent on the board. Well, so easy, right? All you have to do is count how many minions you have on the board on your opponent's side, and then multiply by the number of damage, and voila, right? So just did that, and I look at these numbers, and I'm like, whoops, there is something completely wrong here, right? I mean, I show it to Celine, and you're like, well, you know, if you have 2 minions, your card is already worth 13 points of mana. I'm like, well, model is going wrong somewhere. Doesn't make any sense. You can't have a 50 mana worth of card, so what's wrong? It turns out it's because we use a board damage. Remember I told you we tried to be clever and separated single target versus multiple target? Turns out it's already factored in the card. And this is what happens when you try to be too clever. So like, okay, let's just burn it. Let's try again. And go back to single target. Way better. No, now it makes more sense. That's how we learned that you should not use multi-target versus single target. You should use only one coefficient, which is spell damage, not 2. And then it actually makes sense. Now the card become a good deal when you have 3 minions on the board and not otherwise. Same thing, the graph looks perfectly fair. You can see it visually. Sometimes it's undervalued, sometimes it's overvalued. Most of the time it's between the two, so the card is perfectly balanced. And the lesson learned here is don't try to be too smart. Do not split single and multiple targets. That was one of the lessons learned. We also like this idea because it's actually, looking at those cards help us validate that what we do makes sense and everything is consistent, and when there is something strange we see it and we are able to adjust the model accordingly. So let's switch gear a little bit. we're going to tell you about how you can predict your opponent deck. And I'm going to let you, Celine, tell you a little bit about that.
So hello everybody, my name is Celine and I'm going to show you our in-game tool. So the tool is a web application written in Python. It runs on a small web server called Flask. So you can display the web page just text to your game, as you can see on the left side of the screen, or you can also use any devices with a web browser, such as a tablet. So this tool implements all the algorithms described in this talk, so you can benefit from them easily. So the main screen in our tool is a real-time dashboard, so you can use it to track game metrics, played cards, and predicted cards for your opponent during a game. So the first box on top displays the game metrics. There are 3 metrics. So the mana advantage, so it's the difference between how much mana you spend and how much mana your opponent spent by playing cards. The draw advantage is the difference between how many cards you drew and how many cards your opponent drew. And the other advantage, so it's the difference between how many cards you have in hand and how many cards your opponent have in hand. So this matrix appears in green if you have the advantage, and in orange if the advantage is for your opponent. So in our study, we found that those metrics are the most predictive of the game outcome. So we won't go into detail today due to lack of time, but we will do a blog post later about it. Below the metrics, you can see your deck. So you can see how many cards of each type you have in your deck in the T column, so T for total. Which one of them are currently on the board in green in the P column, P for played, and how many are dead in red in the D column, so D for dead. So below your deck, there is a third box that shows what cards your opponent played. Every time your opponent plays a card, it will appear in this box. Same with total card in the T column, played card in the P column, and dead card in the D column. And so the last but not least, the final box will show you a prediction of which card your opponent is going to play based on the previous card he played. So how did we manage to get the game data? So we could use packet sniffing to get the game data. It gives you the best data. It's a violation of Blizzard's terms of service, so we didn't use it. We could use OCR for optical character recognition, so it gives you good data, but it costs a lot of CPU and it's not very reliable, so we ruled it out. So we ended up using the debug log, so you can start your game in debug mode using a small config file. It's a simple method to get Hearthstone data, but it has some limitations. Like there's only game data, you can't see your opponent name, player ranks, or which card attacked which card, and there are also no info about decks. So it would have been great if Blizzard provided a log system as good as the one in World of Warcraft. So now you will see our tool in action in a short video. So the tool is on the left side of the game. So I'm playing against Elie, and so I choose my card, and then you will see that Elie starts with an extra card in his hand because he has the draw and hand advantage. Now I'm picking up a card, so we have the same number of cards as you can see in the dashboard. There's no more advantage for Elie. So now I'm playing Argent Squire. So you can see the card will appear in green in my deck, and I spent 1 mana point, so the mana advantage is for me. So now as the game evolves, the dashboard reflects the changes, and as soon as Elie plays a card, the prediction appears at the bottom. You can collapse your deck to get more room for your opponent info, and now he's going to play Eviscerate. And let's get a closer look. So Eviscerate was in the prediction. So yeah, it's working. And at some point, he tries to kill me with Leroy. And good for me, I have a nice juggler. It saved me. So I hope you liked it. So in addition to the real-time dashboard, you can also see the current game history in the turn screen. So it allows you to see what happened turn by turn during the game and learn from your mistakes. So our tool will be available next week on GitHub. So we currently need help with to improve deck import using OCR because we currently use a text file. So we also want to display the game history and do the macOS and Windows packaging and improve card modeling. So if you want more info, don't hesitate to talk to us after the presentation. Thanks. Back to Elie now.
All right, before you get all your hopes too high and tell you about how the black magic is done, just a word of disclaimer. Because Naxxmara, which is the extension, has just been released, the meta is quickly shifting, so the predictions are not accurate. As I said, we don't have access to a lot of games, so it takes a while for us to build a model. So expect the tool to not perform very well for the next few weeks. That being said, it will catch up as soon as the number of cards has been released and stabilized, so probably next season, which is August, end of August, I guess. So how does that work? Well, so it's very simple. We model card affinity, which is which card play with each other. Then we have an evaluation function which will return what are the most likely affinity to be played based on previous card played by the opponent. And then we have a tool. The tool goes through a bunch of replays and then learn from those replay card affinity and what are the metrics. And then, as Celine showed you, we have this tool in-game which basically as the algorithm, here's the card which has been played, please return me what are the most likely cards to be appear. That's basically what it looks like. We're going to see each step at a time, and that will be the last part of the talk. So, card affinity. As I said, Hearthstone have about 500 cards, so if we were to look at all the card combination, it would be almost impossible. Maybe like for 30 cards in the deck, we'll have like close to an impossible number of combinations. So what we really do is we exploit the fact that in practice, cards really work well together, and some cards do not work well together. Like if you play Druid, you have the combo, and the combo is Savage Roar plus Force of Nature, so if you have one, it's likely you have the other. On the other hand, you do not have Force of Nature and, I don't know, a Murloc. Doesn't make any sense, so this is not an affinity that you need to model. So we model affinity like this. How we do that? Well, we use the simplest thing you can think of, which is called n-grams. Here is one of the simplest versions, which is called bigram, which is modeling pairwise of cards. So what we look at is we look in the replay at the sequence of cards which has been played by our opponent, regardless of the turn, and we say, well, the Armor Smith has been played, and then the guy plays the Taskmaster, so that's one bigram, and we record the affinity between the two. We say, well, if you play the Armor Smith, then you're likely to play the Taskmaster. And then we look at the second part of the stream, which is, well, the Taskmaster is followed by the Acolyte of Pain, so we record also there is an affinity between those two cards. That being said, we know that the cards are drawn at random, right? When you get one card at each turn, it's at random. So to model that and account for that, we relax the assumption of order, and we use what we call unordered n-grams. And here are unordered bigram, where we say, well, let's take every pairwise. If you play sometime during the game Armor Smith, then later on you're likely to play Taskmaster. If you played the Acolyte of Pain and you're a warrior, yeah, and you are likely to play Armor Smith. And so we keep those. We also tried trigram, which is triple of cards and so forth. Turns out that the best model is the least constrained one, which is bigram. So how do we evaluate card affinity? Well, very simple again. The opponent played, let's say, Deadly Poison and also Shift, which are two cards. So then from there we say, well, what is the affinity of those cards? Well, for Deadly Poison, we know that Fan of Night has been seen 500 times. And then Blade Fury has been seen 350 times. So we look at those. And for Shiv, we know that Blade Fairy have been seen 400 times. And if you play Shiv, we also saw the Harmony Berserker 400 times. So we combine them. And again, it's very simple, the simplest strategy, which is like we just sum. And we say how many times those cards appear, you get the ranking. And the ranking is Blade Fairy is on top because it's 350 plus 400. It's followed by the Fan of Knife, 500. And then you put a cutoff wherever you want. And you say, well, this is my third prediction, doesn't make it because I only want 2. So I discard the Harmony. That's how it works. It seems extremely simple. Turns out if you do something more complicated, it won't work. I try more things. Actually, this one works really well. So how did we did? We took 550,000 replays. And we did 1 model per class because each class has some unique card and we didn't want to have cross trim. And we run the code. Well, first we write the code, but then we run the code and we learn the thing. And then we run. But actually the algorithm run basically the 550,000 replays in less than 3 minutes. So it's not that much work. And then victory. I was actually shocked at how good the thing was. By turn 3, the highest prediction have a 97% chance to be played, which means that out of 100 games, the first prediction that the algorithm return at turn 3 will be played. Sometime in the future, we don't know if it's the next card or the card, but it actually tells you, yes, this card will be played. If you want to look a little bit deeper, this is the curve of the average prediction of the algorithm for 10 predictions turn by turn. You can see it actually rise because you get more and more information as turn plays. The more cards the opponent plays, the more we can look at affinity, so the accuracy increase, and then it starts to decrease after turn 8 because there is less and less cards in the deck of the opponent, so you have less and less chance to be right? I mean, so the balance is somewhat between turn 4 and turn 8. If you look at the ranking function do work. The green represent our best prediction. The orange one represents our lowest prediction, which is at number 10. We choose to cut at 10. And you can clearly see that the best one is actually extremely good, up in the high 90s starting turn 3, whereas the lowest one is barely above 20. And they are converging because the algorithm makes less and less mistakes, but there is also less and less room for errors as turn games progress. So there was a lot of things we wanted to tell you guys, and hindsight we should have took 2 hours and not 45 minutes. We didn't know where we were going when we applied for the talk. So we wanted to tell you about predicting the game outcome. Again, we'll do a blog post. We also are looking into optimizing deck for mana throughput because we know that mana advantage is the key factor to win. And also by popular request, we got requests for looking at hero power comparison and also comparing various deck of type, like why Zoo is winning versus control, how it works, what is the parameters, some kind of stuff. So that's the thing we are looking forward to do. If you have ideas of things we would like us to do, or if you have ideas of things we should do together, please tell us. We would love to do it. We'd like to finish by giving a huge shout out to a lot of people who give us feedback. Thanks a lot. We do read Reddit comments. We do read a lot of comments that people post to us. It's really important. It helps us to get better. Constructive comment, please. But that being said, a big thank you to people. In particular, we'd like to thank Neil and Zach, who spent a lot of time helping us prepare and also give us insightful feedback. And as we said, our anonymous friend who gave us a replay. So thanks a lot.